A person spins a slingshot in a horizontal circle at a constant speed. The sling is 1.8 meters long, and the stone has a mass of 60 grams. The tension in the string is 5 newtons. When the string is released, what will be the stone's speed? So first, let's convert the stone's mass of 60 grams into kilograms. So this becomes 0.06 kilograms. So that's the unit we'll use in our calculations. So now if we think about this, let's say that this is the stone. And there is a tension force pointing towards the center of the circle. You can say that this is the center of the circle. Center of the circle. So we're also going to set our positive x direction to be in this radial direction here. And while this stone is spinning, we only need to know the horizontal forces acting on it to figure out its horizontal velocity, or when the stone is released. So we can simply say, use Newton's second law that says that the net force, or the summation of all of the forces, is equal to the mass times acceleration. This time, tension is the only force acting in the radial direction. So we're just going to say that the tension force is equal to the stone's mass times the acceleration towards the center of the circle. This is the centripetal acceleration, or the radial acceleration. And this is what keeps the stone in orbit, or in this circular motion. Without it, the stone will just fly off in a line tangent to the point it was released. So we also know that the centripetal acceleration is equal to v squared over r, where r is the radius and v is the linear velocity. So now we can plug that in to say that the tension is equal to mv squared over r. So now we just use some simple algebraic manipulation to get that the velocity is equal to the square root of the tension times the radius divided by the mass of the stone. So I'm gonna write this over here a little more. Velocity is equal to the square root of the tension times the radius divided by the mass. So now we just plug our known values in. Our tension is given to us as 5 newtons. The radius is given as 1.8 meters. And the mass of the stone, we converted 60 grams to 0.06 kilograms. Now, if you solve this, you should get that the velocity is equal to about 12 meters per second. So the velocity the stone's speed when the sling is released is going to be about 12 meters per second. And that is how you would solve this problem here.